Thank you for joining us for Making Computational Methods Accessible, our Big Picture Tidyverse, and Data Wrangling with Jae Kim, Ph.D.
For this, look, Berkeley, I think the approach is more like, okay, so you are a smart person, that's why you are here. And then so if you can learn it, that's great. If you don't learn it, just work harder, then there will be no problem. But I have a problem. Then how can I fix this? So that was me in my first year. And so the next year, like I decided to teach undergrad stat because I need to understand stat better. And I feel like I'm missing something at the very fundamental level. So I decided to teach that. And I got a teaching award for the teaching undergrad stat. And then when there was opportunity for me to teach a graduate level computational methods course, I volunteered. And then I decided to teach it. And the reason is because I feel like I felt something that's missing in the way we teaching about computational methods. And I wanted to understand why is that. And then, so I want to be a better teacher, I want to be a better learner. So I taught that computational methods course at Berkeley 3 times. So once as a teaching assistant and then twice as an instructor. And after that, I taught other workshops at Berkeley and other places. And also I've been reading a textbook about learning art. And I think that's why I'm here. It's not because I'm great. I still have imposter syndrome. Whenever it's like people coming to this session, I feel like, what should I say to this wonderful group? I don't know what to say, but I'm here. And then the reason is like, it's, you know, I'm a learner, so I actually ran 10 kilometers this morning. And like the reason I like learning is it's like there's something you can learn from learning, which is it helps you understand that challenge is a way to grow, learn, and mature. So I believe the same thing. So even though I feel this is a little bit difficult challenge for me, I take it. I'm sharing my experience so that we can learn something together and then grow together. So like back in my first year, one of my teachers saying like, you know, he forced us to stand up and saying like, I'm a statistician all at the same time because they want to give us some kind of confidence boost. But that didn't work for me. So what I want to say instead is we are all in this together, right? I think that's the important thing that we need to keep in mind. So when I remember my first year, there were not only me, there are many people who struggle, but over years they became very successful, and then some of them actually become kind of applied statistician, or other people become very fluent in like using kind of method they want to use for their research and work. It happens, though it takes time and effort. So that's the emphasis I want to make here. So let me first put a link in the chat window. Just give me a sec. Okay, there you go. So this is the link you guys all should get access to. So if you check the chat window, I just shared the link. So please go to the link. And then what you can find there, let me see, is this GitHub repository. Can everybody see this? Again, if you can see this, that type 1 is great, or just, yeah, thumbs up is also great, or you can just nod your head if you, yeah, that's great. And the next thing you need to do is click this launch binder. If you click this, if it's the first time, it's going to take a little while, but don't worry, eventually you get there. So the idea is, I mean, there are 2 ways I can teach this stuff. One is I ask you guys, install R in the iStudio on your laptop or on your personal computer, and then follow me along. And the other option is I'm doing everything in the cloud. So the way I'm doing this is a second option. So we are going to do that using the cloud. So using the cloud, what that means is we're going to do everything in the web browser. So as you can see that now I launched iStudio in the cloud. So it's my web browser, but it's also iStudio. Everyone getting so either is a binder of functionality of Jupyter. You can think Jeremy pretty much asked the question is a binder of, the question is whether it's a binder functionality with Jupyter. It's more like an extension. So the idea is it's like, everyone has different, so your laptop is different from mine because you are using different hardware, software, operation system, and so on. So like if you got my code and trying to use that in your machine, that you might get some difficulties. So data scientists, computer scientists develop a concept called container. So what that means is I'm getting the exact copy from my machine and then make that available online using an image, and that's what a binder is about. So it's not exactly Jupyter. So because a binder can contain Jupyter or iStudio or whatever. So you are so if you can open this iStudio on your web browser or you're getting there, then please type 1. If you're still like taking time, that's totally fine. That's great. And if you open the core, there are 3 R Markdown files. If you don't know what is R Markdown file, that's totally fine because I'm gonna explain that to you as well. And the other thing that you should do or should take advantage of this session is asking questions. So there are 2 principles about asking questions whenever I'm teaching a class like this. One is there is no dumb question. So every question is good. So if you feel like there's something you don't understand, just ask me. Ask me as many times as you want. So that's the first principle. And the second principle is, I think you might have a question. Is it your preferred method? I feel like this is something that always pops up. So Jeremy asked me another question. It might be an obvious question. Is this your preferred method of collaboration? I feel like there is something that always pops up with R. So to me, like using binder is not exactly for collaboration. It's to me more about teaching. So if I give you like a little bit more background, so Berkeley having a division of data science, it's for the undergraduate education, and it's one of the most popular. Why should we click on your page to get the iPage you're on? Okay, so let me go back to this GitHub repository. So Nico, if you see this launch binder button, just click this, then you can get here. So yeah, so going back to the Berkeley undergraduate education. So Berkeley has an undergraduate division of data science, which is nearly popular, and maybe it's too popular. So I cannot recall exactly how many, but like there is one large intro data science course. And as far as I remember, it's like more than 1,200 or 1,800 students taking it in a semester, like 1,800 students. And it's a lot. And then they need to do they need to follow along during the session and then everything. So the way Berkeley doing data science at the scale is doing everything in the cloud like this. So that's what I'm doing here as well. And the other advantage of this approach for teaching is you don't need to worry about installation and configuration kind of issues. There are lots of installation configuration issues whenever I'm teaching a data science course, whether I'm teaching Python or machine learning, whatever. And the reason is everyone using different laptop, different operation system, and so on. And these differences cause difficulties. Okay, so you guys are doing good. Yeah, so whenever you feel you have a question, just ask me. Can I contact you later about how to connect iStudio Cloud to the binder? Yeah, so that's exactly something that I can cover Monday. So today is more about actually learning on, and then Monday I can talk more about what are the kind of best experience or the tips that I have for teaching at scale or teaching for students who have kind of very little background, technical background in R or computation or statistics, things like that. So my understanding is either you have a background in R, Python, data science, statistics, whatever, or you took the I bootcamp designed and taught by Yeah, designed and taught by Chris Bale at Duke, and that's amazing class. So I think that you guys learned a lot from that one. So even though I'm teaching R here, like the kind of thing I'm trying to teach here, I will teach or share. I think it's the precise word is sharing, not teaching. Sharing here is not exactly teaching you R. It's more about like teaching the framework to learn R or programming language as a social scientist. But that's something that I felt what I missed in my first year, and then I'm trying to identify and then teach my students in like throughout my teaching career. So what is the better way for us to understand R or understand programming language and apply it to our research? Okay, so if you're able to open this, first go to this pane, and then you can see that there's a code directory and click it, and you can see there are many numbered files, and obviously click the first one, 01_ setup. And I'm checking questions. Yeah, so like Regina said, click on the code and you can see those files. And then you need to click the first one, 01 setup RMD. And does anybody know what is RMD? Yeah, I marked down. And like I said, if you don't know it, that's totally fine. And so here is it here anyone who has never used RStudio before? I have zero experience in R and please type 1, which is actually nearly good because you know, you are learning something new and something exciting. Yay, we have good company. Welcome you guys. So if you're using the RStudio for the first time, it might be a little confusing because there are just way too many things going on here. Well, okay, so you got into file, right? File makes sense, but why is a project here, right? It doesn't make sense. And here's edit. Yeah, copy and pasting stuff. I understand that, check spelling makes sense. But how about code and like there's insert chunk, whatever, and then view, plot, session. What is session? I don't exactly understand what is session. And there's a PO, and there's debug, there's profile, and tools and help and so on. So I don't have time to explain every single detail about R and RStudio, but I'm trying to demystify as much as possible about these 4 processes. So there's like so if you think about cooking, I love cooking. So aside from running, if there's one other thing I love, which is cooking. And when I'm trying to first learn cooking, which is so hard because there are just so many different cuisines and so many different recipes, and I have no idea where I should begin. Then one day, just like when I'm randomly searching the internet, I found a book from Amazon, which is called the Food Rap. And it's kind of naughty book on cooking. So what are the kind of scientific principles about cooking, and then what are the like big paradigms there? So when I click on the RMD file, nothing opens. So you click this one, 01, and you get this file or not? It won't open? Okay. So you click this and then you got here. And then so you are in the code and then you see these 6 files, Regis and Ebony, can you see those 6 files?
I can unmute. Yeah. Yeah, following all the
instructions, but still not seeing it.
No, nothing
I'm
open.
in the same situation.
Yeah. Maybe maybe you need to relaunch the binder. I think there's something happened in the process when the binder is organizing files in the process. Yeah, but like in terms of like following the materials, there will be no problem. Yeah, but I'm happy to go back if there's something I missed because you don't have the materials on your hand. Yeah, but thanks to point out. Yeah, so another option is to start the file and run locally, or you can just if you go to the binder, and sorry, not the binder, the repository, you can just create code and then click the file and then see the code here. But I feel like this is more interactive, so that's why I prepared this environment. But for whatever the reasons, if this is not exactly working right now, there are other options. Once I refresh it, okay, yeah, good, sounds good. Okay, so again, like every semester, every class when I'm teaching this, like configuration, installation kind of stuff, takes at least 1 or 2 days. So it's normal experience. So like going back to like food analogy, there are so many cuisines and there are so many recipes. But one thing I learned from that nerdy book about cooking called the food rap. So if you're in cooking, I strongly recommend that book. So I'm not the author. So basically what the book teaches is that there are kind of 2 big paradigms in cooking. So one is fast cooking, and then the other one is slow cooking. So fast cooking is like a stir fry. So if you got a strong heat and like lots of oil and then put the meat or veggie in it and then cook it, that's nearly fast. That's a fast cooking. And the other method is like a slow cooking, like making soup. If you think about the process of making a chicken soup, that's a slow cooking. And if you think about like these whole details, and if you're like, trying to learn every single detail about it and then getting it right, maybe it's too much. So the first thing like you might want to start to do is like thinking about the big paradigm behind learning programming or R, RStudio, and then become familiar with that. And they can give you confidence and kind of framework to work with to learn more details later on. So that's why I'm first starting with R and RStudio. So what is R? Short answer is R is a free and open programming language that helps you teach a computer to perform a data science task. So free meaning this is free, like we don't need to pay money to use R. It's free available. And open meaning like everybody can contribute to R. So you can write your package and then contribute to the and make it available to the repository something, and then anyone can use it. And then what is data science stuff? Because R is originating from a language called S. You don't need to about the whole detail about the history. The point is from the beginning, R is designed to do data science, like statistics, like very highly computationally intensive, numerical computing kind of work. So if you got lots of data, and if you got like want to do a lot of model and then do something and then visualize them and then communicate it, then R is a perfect language. So and here another point you might want to see is that this teaching computer element. So what do I mean by a teaching a computer? So here what I'm doing is here's the console side. So there are 4 sections in R. So this is a file, this is environment, this is a source side, actually not console, source side. It's a kind of like an area where you write a recipe. And then this is a console area. And then there's a console and there's terminal, right? So what is terminal? So I'm kind of old, I'm not that old, but I'm kind of old millennials. What it means is when I was young, there was no GUI. When I was young, when I first got used to computer, there was no GUI or graphic user interface. The graphic user interface is basically like if you can do things, everything, you can do everything using your computer, using just your mouse, like point and click. That's a graphic user interface. So I think perfect example is maybe iPhone, like smartphone, and then like your tablet. So you don't need to type anything. Most of the times you just need to point something, clicking it or touch it, then it works. And there's another way you can communicate with your computer, and then if you do that, maybe that's more that's the moment when you're thinking more about teaching a computer. So here there's a console, and there's another thing is called terminal. And then if you type ls, this is basically ls means list. So computer scientists, programmers, they love using shorthand names because they don't want to type. So instead of typing list, we are typing just ls. And this is called a command. And what this command do is like it's telling computer, okay, please show me the list of files in this particular directory, right? And then you can see that there's install.r file, read.md file, and so on. And there's also another, directory. You can know that this is directory because it's in different color. So for me, this is blue. So core directory and so on, right? And actually, I can hello Howard, something like this. So echo is same as print in our Python. So what I just did is asking computer, please printing this statement. So hello Howard, and you can see that. So there's terminal, but what I'm doing here is a Unix, it's not R. But if you just want to use R, that's when you are using this console. So terminal is a kind of more general environment, and then console is a kind of more specific environment. We are only using R. And this environment thing is actually kind of little confusing, especially when you are beginning, just getting started in programming on R. So the way I think about this is kitchen. So again, cooking analogy. So if you think about your kitchen, there are different sections in your kitchen. So one is like your sink, where you I don't know, rinse stuff, and then that's the area for that. And there's an oven, when you're baking, and there's a microwave when you're nearly like heat up something near quickly. And then there's maybe so like the oven, and then sink, and then there's a fridge and microwave. So different areas and different devices and so on. And then you are doing very particular thing in a very particular area, right? So that's how a kitchen is designed. And if you think about this iStudio and how everything is designed here in a similar way. So maybe this is this is a place where you're writing down your recipe. Okay, I'm gonna cook chicken soup this evening, this dinner. So that's what I'm gonna do. And then this is like actually when you are executing that. So I'm gonna boil the water and the stuff. And this is where your ingredient is, like whether I'm gonna have chicken or some, I don't know, garlics and stuff that's all here. And then like this is maybe your fridge, So there are different sections in your fridge, and then one section is for veggie, one section is for the meat, and the other, and so on and so forth. So that's one way you can think about these different panes or sections in RStudio. Okay. So that's about R. So R is a language that you can use to teach computer to do data science work. And some of you might use Python. I also use Python, and Python is pretty popular. And so at SICSS, we are using R, not Python. And I think there is one reason for that. So this is an explanation coming from, so the short answer is either language is fine. So you can use whatever language that works for you, whether R, Python, Julia, or so on. So to me, it's like, what cuisine is the best? You can cook whatever food you want that you like, because it's, more satisfying for your taste, or that's more consistent with your upbringing and whatever. So whatever that works and then creates food that you like, that's the work that we want to do. But there's some kind of cuisine is more difficult for you to learn, and then others not. So the reason why, especially for social scientists, we are teaching R is because R is more accessible actually. So Python is great language. So if you're actually like programmer, if you want to learn computer science, how it works, then I recommend learning Python, because there are some fundamentals that you are kind of forced to run if you're trying to learn Python. But if you're using R, you don't need to learn those fundamentals. You skip that, and then you just do whatever you want to do. So if you're a political scientist, I'm a political scientist. If you're a political scientist analyzing election data, if you're a sociologist analyzing criminal justice data, like crime, policing, jail kind of data, you can do that. You can do that pretty quickly and pretty easily. So that's a huge advantage of R. So I'm going to skip like the problems, limitations are, and then how our community has addressed it. But the key point here is R also has lots of problems, but many of the problems have been solved or in the process of being solved. And like one of the major contributions is made by RStudio. So I think you might have, RStudio is actually also company. And they made a product is called RStudio, so same name. And especially this guy named Heather Wickham. So have you heard about him, Heather Wickham? If you heard about him, then type 1. If you never heard of him, then type 0. Type 0, yeah, true. Sounds good. I kind of mixed the response. So if you're in the data science community, Heather is a kind of Beyonce kind of figure, super popular, and everyone loves him because he single-handedly contributes so much to data science, especially on the R side. So like so many packages you're using in R, for example, dplyr and userplot2, and just so many they are his inventions. So userplot2, the visualization tool, is actually his dissertation project. So Heather is awesome. So, but that's not the point. So you can install R, whatever operating system you are using, whether you're using Microsoft Windows or Mac OS or Linux, you can do that. But there are kind of different ways you should do it. So if you have questions about them, please go to this R project website and then please refer to their guideline. Yeah, you're right. So R is the range. So actually, I'm going to show the kind of image there. So let me meet the file. So Yeshi commented about the difference between R and RStudio. So to me, like a perfect analogy is the difference between engine and dashboard. So if you think about R as you can think about R as an engine in a car, and then RStudio as a kind of dashboard. So like as a driver, you don't actually need to know about it, how this whole machinery works. So what you need to is this handle and this dashboard, so you can understand like what's going on in my machine, and then navigate the road so you can arrive at the destination you want to. So why we are not directly using R in this console or terminal, why you're using this whole setup? Because this is easy. I think this is one of the reasons why we have kitchen. You can cook without kitchen, and we do that if we do cabinet, or like you are, but if you have kitchen, really nice kitchen, a very organized, sectionized kitchen, it's much easier, right? So to me, like one of the holy places in my home is my kitchen, and I care a lot about it. So that's why I'm using lots of analogy. But maybe you have like different places at your home that you deeply care about. Maybe your library, your basement, your garage, I don't know, your garden, maybe. But think about that, like, yeah. But yes, you're absolutely right. R is the program language, and RStudio is, to me, is a kind of the analogy I like is from Modern Drive textbook. R is engine, and RStudio is dashboard. So, okay, so we know the difference between R and RStudio. R is engine and RStudio is dashboard. And then there are different ways you can. So the reason I'm saying is dashboard is because like you are communicating R using this platform or this software or this dashboard. And why we are doing it, I say one is like this organization, and the other thing is because there are multiple ways you can write a program if you are using RStudio. So that's where so there are many, on the tab, there are many many functions. So if you click file tab, you can see the new file. There are so many different file types. And excuse me, sorry. It's automatically going down. Yeah, so the most different, the basic version is script that looks like this. It's just a bunch of code, so I can write something like print hello Howard, and it's gonna print this, right? So you are writing the recipe, and then you are writing, you are seeing how it's gonna be executed. And you can actually comment to this, print Howard. And then when you heard commenting, maybe you're not familiar with what is commenting. So the idea is, even though I drag this whole area and I make it run, you see that only this line number 2 is running, but not the line number 1. Why? Because I used a pound here. So if you use a pound in R, that indicates that it's a comment, and the comment is not going to be run. Okay, so that's going to be running. That's the point. So and why we have commenting? So because, if you think about programming, so earlier I said it's a way you can teaching a machine, but actually programming is a two-sided. So on the one hand, you are trying to teach your machine to do something that you want, but on the other hand, you are communicating with your future self and also other people. So for example, you are working at a lab and you have other teammates, and they need to understand what you are doing with your R code, right? Or you are writing R code, and then maybe months or years later, you want to go back to your R code and they understand what I did there. So in the case, if you can make a little description about what you did here. So print Howard, this is teaching demonstration. And maybe this is easier for you to understand what happened and why you did something. So this is why we do sometimes commenting. And you can see lots of people doing commenting for their code, whether that's R or Python. So this is like using R script. But how about I Markdown? So the idea is the same. So the principle is, programming is on the one hand, it's about teaching computer, but on the other hand, it's about communicating with other people. So I Markdown is designed with the duality or this two-sided communication in mind. But what it's trying to accomplish here is combining text and code in a richer way. So if you look at this I Markdown, you can see this heading. So if you, okay, basically I'm going to show you two things. One is that if you want to write a code, you first need to define this is area for code. And this is how you can do that. Code chunk, right? This is called code chunk. So if you create a code chunk using this tagging, the R tagging, and then it's going to be indicated by this gray area, and then you can write some R code here, right? But if you're trying to do the same thing without this code chunk in the R Markdown file, that's indicated by this file extension .rmd. This is not, yeah, this is actually working. This is weird, but normally should not work. So that's the point. Oh yeah. So for example, so this thing, if you're trying to run this thing, this does not work, right? Because it's not correct. So actually, yeah, you can put the, but you should. So you can put the code in this area and you can run it in the console. But if you're trying to need this and then create this, so you can write down in the R Markdown file and then turn that into a report, like using HTML extension, or you can turn it into PDF file or MS Doc file. Then if you put the code in this area, not in inside this code chunk, that's not going to work. That's not going to be included in the output. So that's why, so in this setup, it's recommended that you're writing code inside the code section and then you're writing text outside the code section. Yeah. So that's what's nice about iStudio, and then you can include, like quote like here, and you can differentiate headings. section heading. So this is a section, subsection, and so on. So you can organize the different areas in the file. So that's why iStudio is awesome. And also you can turn this iMarkdown file into different formats: HTML, PDF, or Word. So that's another nice advantage of using iMarkdown. So there are many benefits of using iStudio rather than directly using R, especially for the beginners. So iStudio is great. So getting started in R, is iMarkdown more standard than just using iScript? And it depends on so Erica's question is R Markdown more standard than just using iScript? So that's actually like excellent question. So to me, and it's in my experience, if you so there are two occasions I feel like iStudio is extremely useful. So one is teaching, because when you are teaching, like you need to combine larger materials with code, like images and text and so on. So that's a great case. And the other one is like when you're actually experimenting with your course, so you don't exactly know what you're doing, but you need to find the ways. Then Markdown is great, because this environment is super interactive. But if you want to put your code in production, so code in production meaning like you are not only using, you are not the only using your code, but you want to share your code with someone else, and they're going to be the people who are going to learn that code. Then it's better to put iMarkdown into file, into iScript. But actually, it's also pretty easy to turn iMarkdown file into iScript. So in a neat package, there is a function called per, and using this per, I think this is right. If I'm wrong, I'm gonna look it up and then find the exact function that you should use, but I think this isn't right. And then using this one, actually, you can turn iMarkdown file into iScript. So turning from iMarkdown file into iScript is also pretty easy. Just using one function, and then it'll be done. And you might wonder about this colon thingy. So basically, this means from this package, this function comes from this particular package. Any more questions about this? Okay, so we cover R and iStudio, and then why iStudio, when iMarkdown could be great, and console. And then let's talk about a little bit more about console, because you use iStudio a lot and iMarkdown a lot, but at the same time you need to understand this environment, this section, like what is a console. So if you look at console, you might see this. This is saying it's a prompt. It seems that it's an area. This line is going to accept the command. That's what this indicates. And yeah. So and then the other thing you see that it's a blinking, and it means it's ready to accept the command. So actually you can type something like you did before, like print hello something, and then it's gonna work. And then for the basic syntax, I explained why is a comment and why you're using it. And the other one, maybe you need to keep in mind is this something called assignment operator, and maybe variable. So far, if you look at this environment, you can environment section here, environment is empty. And for the experienced R users, I want to question you, like, what is a kind of basic question? What is the environment, and what is variable? Can you define like these concepts in your language? It doesn't need to be like 100% accurate, but like I want to see like what is your intuition behind them. What is the environment, or what is a variable? And after this, we are going to take a break because you might get a little bit tired. What is environment? What is a variable? Have you thought about it? Because like whenever using iStudio, there's there's source pane, and then there's an environment pane, and you see that. But what is environment? So the environment is where data frames and variables that you have vetted into R are stored. Holds your data frame vectors, environment level, save object, library. Yeah, for Lego Veratom. Yeah, these are all great, and you guys are right. So the intuition is correct. So basically, let me give you one example. So where is it? Okay, here, assign operator. Why? So I'm creating one object. So everything you do in R is object, and everything you have in R is object, and everything you do in R is function. So I'm going to explain that later. But that's just to put a moment, bear with me. What is it? Just to not think about what is object. So I'm creating an object called a US weird. And then like Todd and Marisa and Felix say that you can see that in the environment is no longer empty, and then you got a pair, right? You got this US weird, and then Y use LB for pound. So US weird is a variable, and then Y use LB per pound is a vector. We call it vector. So if you took the R bootcamp, you might know about what is vector. Vector is just a homogeneous single-dimensional type of data. That's a very technical term. So vector is basically like if you have 1, 2, 3, something like this. This is a numeric vector, and then instead you have something like A, B, C. This is a character vector. You see the idea is, so every single item in this bucket is container. They're same type, right? So it's all character. It's all number. So this is numeric vector, and this is character vector. So here I'm creating a character vector called Y use LB per pound. You can do this by just using string quotation, or you can do this using C. It's concatenate, and you create a vector, and assign it. Assign means this. Assign is the assignment is done by this operator, and then we assign this to US weird. So I think this is a kind of very computer sciencey and not very like plain Englishy explanation about this, what's going on. So basically, actually, what I'm doing here is if I'm like trying to explain the kind of hidden context here. So basically, I'm naming this statement Y use LB per pound as US weird. So you can think of a variable as a name, okay? As a unique name of an object. And here the object is this vector or this statement, Y use LB per pound. And if you look at the environment, what you're seeing is actually the pair. So one is the name, and the other one a variable, and the other one is actually the content. So here the content is this character vector. Y use LB per pound. And I use this example because as someone born outside the United States, I found this, when I first look at this, it is very confusing. Can you also use, so Erica's question is amazing. So actually I have the explanation for that. So if you come from like a Python, Java, or other languages, maybe you are more familiar with using equal sign rather than this arrow sign for the assignment operator. But in R, I want to caution you to not do that. There's a reason for it. So let me give you this example. So here I'm creating, first of all, I'm creating this vector. So this is a sequence of number from integer from 1 to 10. So let me just first do this, right? So if I do that, you can see this creates a sequence of numbers, integers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I can assign this using either X. So I first use the standard one. That's going to be, arrow assignment operator. And you can see that it creates a variable. You see the name here, X, and then you see the content integer 1 to 10. Or you can use same thing, but this time using the equal assignment operator, and it's exactly the same. Or if you are still maybe not very confident about the process, I first delete the X variable and then create again. You can see that it's exactly the same. So maybe you feel that maybe there's no difference between whether you are using arrow assignment operator or equal assignment operator, but actually they are not exactly the same. So I'm creating these creating X vector using in this case in line 118 using equal assignment operator, and in line 120 using arrow assignment operator. And then I'm gonna calculate the mean of these vector. So what is the mean value of these series numbers? So if I do this, it calculate, let me first remove RMX. So RM means remove. So I remove X vector. And then if I do this, yeah, obviously we calculate the RM, so mean value, and it doesn't save anything. So it's just a US value is there, but not X. But if I do this, can you see that? It's saved. So it's kind of weird. So the bottom line, the principle you want to remember here is if you are assigning something, naming something inside the function that's inside this parenthesis, you should use this equal sign, but outside the function, no matter what, you should use this arrow assignment. Yeah, so they are not interchangeable, and then there's kind of scoping environment, like it's core technical issues involved here, but I'm not going down there. But but actually as a practice, just remember that inside the function should use as an argument should use this equal, and outside the function should use arrow assignment operator. And then somehow I gave an example that involves something maybe outside the things that we haven't touched yet. One is a function, and the other one is argument. So you guys did a great job explaining what is environment and variable. So can anybody explain what is a function and what is an argument? What is a function? So if you understand object and function, then you understand everything. You need to understand about the basic principles. So I say like in the cooking, there's like two big paradigms. One is fast cooking, and the other one is slow cooking. And then in programming, equivalent to that is objects and functions. Yeah. So Marisa say that functions tell R to do stuff from specific packages. So you're right. But I want to hear like other opinion too. So is there any other thought about this? What is a function? Like I said, if you have a good intuition about objects and functions, and they are like main building blocks. So you can do wrangling, data visualization, machine learning, whatever. Is that the actual command? And that takes us good. So the way you can understand about function is actually defense comment that take objects inputs. Yeah, so you guys are all on they're all good and they're on the right track. So, but like, let me kind of define it in a little bit more precise way. So a function is basically, a function is a process, computational process, not just any process, it's a computational. That takes certain inputs or particular inputs and then produce particular outputs. And one great example is this mean function here. So this is a function. And how come you know this is function? Because you are using parentheses. And why do you need the parentheses? Because you need to pass into some input. So here the input we are passing in is x equal 1 to 10. But actually you don't need to use this. You can just do that and it works. And it takes this input, this function takes this input and creates this output and returns this output. This is function. And then going back to Melissa's point, function tells us to stuff from specific packages. I mean, sometimes functions are from packages if other people have already built these functions for you. Or you can build a function that you want. Like, for example, let's say combine. This is a function that I'm going to build a function. And then you just take one input called A. And then it's just to do it is, okay, let's print something. Yeah, so it's actually basically a print function. It doesn't do anything else. And then if I do this and Howard, you can see that it prints Howard. So this is kind of analogy of function. You see that there's an input and there's an output. And you can make it specific, this is output, by saying this is return. And again, like, when you're creating a character vector, when you're creating a function, you can give a name. So here I gave a name, and the name is print something. So you here in the environment, you see that like it's kind of, kind of freeze. In the freeze, you got like, badge section, this section like this. There's a value section and there's a function section. So now value section, we have 2 vectors, and then function section, we have one function. Okay. And then, so the variable is the name of these values and functions. And then inside the function, like you have this something called like this A, right? This A is called argument. So argument never appears in the global environment. That's the key. Argument is only used for inside the function. So it's like just variable, but it's not just live in there, just not living in the global environment. It's only living in the inside the function. That's argument. Everything clear so far? Or if you have any questions, then please feel free to interrupt me. Yay! So we cover like something very important. Like I said, even though there are so many different, cuisines and recipes in cooking, there are kind of 2 big paradigms. I need to describe how to get started in cooking. So one is slow cooking, and the other one is fast cooking, and the same in programming. One is object, and the other is function. And if you have some good intuition about it, then that gives you strong foundations to do other more advanced and crazy and cool stuff. Any questions? Felix, do you have a question?
Oh,
okay.
Sorry, I got
unmuted.
Yeah,
it's fine. Yeah, so we covered printing, and there's some other stuff, but let's stop here and take a 5-minute break, and then resume what we left, because you guys needed some break. So I'm gonna stop here and then take a 5-minute break. Hello. Everyone back? Or so I hope that you get a chance to get another cup of coffee, or I don't know, tea. So who is a tea person, or who is a coffee strong advocate for coffee? Coffee person 1 and tea person 2. Yeah, what is that? Is it coffee or tea?
Mine is weird because it's like 25% coffee and 75% milk.
Oh, okay. Yeah, that's my wife's preference. Next thing, say previous tea, my partner converted me coffee 2 years ago. Yeah, that happened to me as well, but then I kind of converted back to tea recently. It's kind of back and forth. I don't know, but caffeine is somehow, I never live without it. I don't know when I can do that. Someday. So, okay, let's get started. But before moving on, I'd like to open the floor and then ask you some questions, because I want to be this kind of more like interactive session, having a dialogue rather than just me lecturing, because it's me sharing my experience and also like you guys sharing your experience as well. That's what I'm hoping. So what I want to ask you here, either you can say something, either unmute yourself or using the chat, whatever you prefer. So what is the area, or what's the thing that you find most difficult when you're trying to learn R? So I've been learning R or teaching R 7 years, but still, like, I don't think it's an easy subject. So I totally get that if it's if you feel it's challenging, but I just want to hear what is a specific area that you feel that very challenging. Marisa?
For me, one of the challenges is kind of being effective. So there's been times where like I spend like hours and hours trying to figure out how to do something, and I end up with like pages and pages of code. And then once I figure it out, I'm like, then I start to truncate it. And it's like, oh, what took me like 30, 50 lines of code, or in all these different broken down steps could have actually been done in 1 or 2 or 3 steps. Right. That's what I'm trying to get more effective at, is like, how do I code more effectively the first time around and save time in my life, as opposed to having to do it after the fact of me trying to figure out and troubleshoot and Google things and Stack Overflow things. So I think that's me, one of the most of the many challenges I have in R, but that's one of them. Absolutely
right. I think let me just hear 1 or 2 more ideas and then like respond to that. So Regis stated to a beginner for understanding the error messages. Oh yeah, our error messages are horrible, so I totally get that. And how to fix those have been challenging. And Maxine says, I still get caught up on debugging. It's hard for me to find errors in my code, also writing functions efficiently. Yeah. And plotting graphics and debugging. That's absolutely right. So how many times, how many people still Googling like ggplot something? They still do. Knowing how to Google what I want to do, that's you don't do. It's easier when you can Google an error message. That's also correct. Yeah, I Google everything. Yeah, so actually the reason that I decided to write a textbook is because I don't want to Google, because I Google once and then I can find information and just to put them together and organize it. Graphing, I have extreme difficulty using ggplot too. Yeah. Yeah, this all makes sense. This all makes sense. Absolutely right. 2 things. One is I think it's exactly the same for writing. So like I like lots of papers and because it's my job. And the way that I work is like I decide like whatever ugly paper I'm gonna write, I'm just finishing it and then just revising it and over and over. And the reason is, I don't know who can do that, but like it's very difficult to write the perfect first draft. So I don't care however rousing my first shamy my first draft is, I just get it done. I just lock myself in a room and then finish it, and then just revise it with a plan. I think that's better. And it's the same for the programming. Actually, there's a specific term and paradigm for that. So the paradigm is there's a code you use. So one is called refactoring. So that's exactly what Marisa described. So I got a clutter of code and I want to make it more condensed and more efficient, right? So that's what described. And for programmers, that's what they're saying, refactoring. So we're gonna find the essential element of the code and then get down to it. And the other one is code reuse. So one of the ways we can become more effective in writing is because you need to figure something out, some framework, I don't know, some ideas that successfully defend you, like for literature review or argument. And then later, if you find a similar project, you can kind of not easily copying and pasting, but you can borrow the ideas that you used in the past and then to the new project. It's kind of same thing. Actually, it's more efficient in coding. So if you got some problem, either ggplot, whatever, and you figure that out, and if you save it somewhere, say like a GitHub repository, and then you can reuse it for your new project. So that way you can become more efficient. And there's other lots of questions about Googling kind of stuff. And actually that's exactly I'm going after starting now. So let's have a conversation about functions. So going back to RStudio. Can everybody see the RStudio that I open here in the browser? If you can see it, then please type 1 so that I can see everyone the same page. Great. So we are getting started. I hope that you have, I don't know, drink or tea or whatever, so you have energy back. So before moving on, so I want to explain some basic stuff in R, but still could be useful for your work. The one thing we did is printing. Printing is like something very obvious. So we do every time we've been teaching, like intro to computer science class, we do this like print hello world. But other than that, it's not very exciting. So I want to explain more about help area. So sometimes you got a function like mean, but like you don't fully understand how you can use the function, or like what is the best example, best way you can use the function. So that's maybe going back to ggplot2. So there are two things. One is like you don't know the function name. So when you're using ggplot2, okay, I want to draw like a bar plot. I want to draw a line plot, but you don't exactly know how to draw line plot or bar plot. If you want to do that, you know and it's something like this, like germ bar. This is bar plot, or this, and then for line plot, this one. So the first thing you need to do is you need to know the names of the functions. The second step is, this is maybe a little bit more complicated. Okay, so you know the names of the functions, but the next step is you need to know how to use those functions. And that's where the list of fx. Yeah, so there's a namespace. There's something called a namespace. I'm going back to Yvonne's question later. So for example, so first let me deal with the function one, function documentation, and then I can go back to the list of the kind of question, the package question that Yvonne raised. That's just something called namespace, and I'm going to explain it just after this. So there's something called documentation. So if somebody wrote a function, like, so basically the package is a collection of the functions written by other people. And they know exactly what those functions are and how they work, but like they also know that other people have no idea how they're going to use that. So whenever somebody wrote their functions, what they do is they document the names of these functions and their usages and like arguments there and so on and so forth. And you can get access to these documentation and see what's available, how you can use it. So for example, there's a very basic function called mean. Then if you just need to type question mark and name of the function, and if you run this line, and then see this other corner here, you can see there's a documentation come up. So this is mean function coming from base package. So this curly bracket indicates that the name of the package where this function comes from. And this is the name, the basic description of the basic name of the function, the kind of extended name, arithmetic mean, and what's the description, uses. And then here you see the argument section. This is exactly what I'm saying. It's a variable, but variables don't live in the global environment, only inside the function. So X is an object, but whatever object can be. So here you can pick X equal 1 to 10. Okay, so that's why this works. Then you're calculating mean of this vector, and then you get 5.5. But let me try y equal 1 to 10. Yay, but it doesn't work. Why it doesn't work? Because if you look at documentation, this should be X, not Y. So only X works here. And there's another, but we also now realize that there are other arguments. One is prim, and the other one is NA, the RM. So this is for like when you have missing values here, and then you want to know them. So for example, you got this, and then you include NA, that's basically meaning missing value. So I concatenate or bring together this numeric vector and NA value. And if I just do this, I got the NA. right? But there's NA here, missing value. And if I want to know that, I can add this additional argument, and add the RM, and then make it true. And now I got this 5.5. And if you scroll down, usually at the bottom of this documentation page, you see some examples. Okay, so this is how usually function is documented. There's name, the description, there's expansion about different arguments, and there's examples. So some of you mentioned about ggplot. So let me give you that example. So if you haven't installed ggplot2, you need to install ggplot2 like this, and then load it. So some of you wonder like, what is a library? So so this is a install step, right? So install. So your computer didn't have ggplot2 before. Now you install it from one of the repositories out there. So you got ggplot2, and then load. So library ggplot2. So I'm using this function called library. This is a function because there's a bracket, and inside I pass this name, ggplot2. But if anyone can explain what is a library function does. So the input is obvious. The input is this name of the package, but what is the output? So I say like a function, whatever, there's a function, the function does is takes an input and returns an output. So can you explain what is the output of this function? So library, load the package. Yeah. Another way you can see that is if you look at the global environment. Here, there is no ggplot2, right? These are kind of the basic packages that kind of built-in packages in RStudio. And if you do this, and if you click here, now you can see that there's ggplot2. Okay. So it seems whenever you're doing libraries and packages, it's like nothing happens, but actually something happens. So if you click this, and you can see that there's a one more package up here. Got it? So now you got a ggplot2. It's a living in the global environment. And if you add this colon twice, and you can see there are lots of functions related to ggplot2. There are lots of functions. Maybe too many. But like one thing, like there's if somebody wrote a function and they know like the principles of writing software, it's like if whenever you're looking at the academic paper, peer-reviewed article, they are kind of like well recognized sections, right? So there's an introduction, there's literature review, there's a theory section, there's methods of hypothesis and data analysis and discussions and conclusion and so on. And it's the same for the documentation for the function and the package. So the function, you can see that there's a kind of different sections for the function in the documentation page. And same for these names of the functions. So if you do this colon twice, what you see is this namespace. It's this area is called namespace. It's basically the names of the functions related to this particular package. And what you're going to see is there's some kind of pattern. So for example, this stuff, chord stuff, it's all about coordination. And there's going to be geom stuff. It's all about geom, geometric area of the graph. Okay. So we are going to talk about plotting later, but this is just to give you some idea about how documentation is organized for the function or for the package. So I found this I found this using this quotation mark. So you can get this function documentation using this quotation mark or using this hash function. So either way, I find this is extremely helpful. And the reason for me it has been very helpful is because I don't need to remember every single argument of a function. I can just look it up using this quotation mark or hash function, and then understand what is how can I use this and how can I best use for my work. And some of you like asking question, okay, sometimes you do Google search, but is there a better way? Another way you can do this is using this help.search function. And if you do that, it's gonna show you functions and packages related to visualization. So obviously ggplot2 comes up the first. I don't think this is much better than Google search because it's almost the same, but sometimes this is very useful because it's quick and fast. So it's just in the, you don't need to go to other space, open up other program, just in the same ISO environment. You can just use help.search and then find the thing that you want. Okay, we cover environment, it's collection of pairs, names, and their content. We already know that. And the other thing that might be useful here is this LS and RM, which I already used, but didn't explain in depth. So I created a vector named X. Its content is numeric vector. So num is numeric vector. And there are 5 elements, 1, 2, 3, 4, 5. And if you want to list them, actually this lists every object. So it lists every object alive in the global environment, living in the global environment. So it shows the print something, US var environment, a variable here, and then X variable here. And if you want to remove a particular object in the environment, you can just give their name as an input. And then using this RM function. So RM is a removing function. If you're not sure about RM, just using quotation, question mark, and then run this line, and you can see that this is a removing object from a specified environment. Okay. Yeah, and then this one is might be popular. So have you ever used this RM list equals ls command? Or have you seen your instructor using this? One? Yes, okay. So the reason why many people using this for the as a first line in the I code is to clean up their session and or the environment. So I'm going to explain then what I mean by this. So one thing there are 2 things you can notice here. So one is RM is a function because it has a parenthesis, right? And then list is an argument, right? Then we set this argument equals ls. And this is like ls, this output is every variable in the global environment. And then list is the list of the items in the global environment, and we are going to removing it using this function. So now you can see that it seems the global environment is clean, but actually it's not exactly that, because if you click this, you see that there is a package equal to ggplot2. So if you use this, it removes your the object you created, but it does not unload the library you wrote it. Okay, so it's not exactly same as you clean up the session. So this, if you do that, RM restart this equals IRS, it's going to clean up the environment, but it's not exactly clean up the everything in the global environment, because you can see that the ggplot2, you install and load it. What that means is, if in the code, if you use something like ggplot2, and if you give your code to your students or your team members, collaborators, they won't be able to reproduce it unless they install and load this particular package. Okay, so this is not exactly the same as creating a reproducible environment. And that's kind of tied to this session. So anybody can explain what is session? What is a session? Again, you don't need to be like 100% accurate or precise explaining what is session. Just give me like some like your intuitions behind this concept so that I can work with it. What is your intuition about a session? So it's kind of one of the mystical feature of iStudio. Instance of iStudio usually tied to project in my experience. Yeah, that's good intuition. Really good. Any other ideas about session? You can type something in the chat or are you aware, like, have you ever like heard about this term, like, session? And then have you ever wondered what that exactly means? If you have that experience, then please type 1, because I want to see that. Yeah, I hope that someone had some curiosity about this concept. I have no idea what that means, to be honest. Yeah, that's pretty good. That's also a good reaction. Instead of year logs, is it similar? Okay, I've seen it, but didn't know what it meant. So Todd, you also wonder, right track. Is it similar to the question? I think it's not the same, but never thought about definition. So one way you can think about session is like it's like a sink. So in the kitchen environments, in the kitchen example. So whenever you are cooking something, like I say I want to cook a chicken soup this evening, and then maybe tomorrow I want to do a French toast. Then what it means is I need to wash the dishes and clean everything up and then stack them so that I can start over. Okay. So session is like you can think about session is one cooking, preparing one dish. That's one session. And then so ideally one session should be separate from another session. You know what I'm saying? So session, yes, because it's instance of program, so that's kind of technical language, but like one way you can understand it more at the intuitive level, to me, and it's in my experience, is thinking about it as like, again, as a cooking. So whenever you cook another dish, what you're gonna do, you need to clean up everything, right? If you're using the same oven without cleaning up, you're then using the same frying pan without cleaning up, then it's gonna smell a little bit weird, right? Because it's like some leftover food, oil, whatever, and then that's just remain there, and then it's gonna be not good. It's the same thing. So, and then what I'm saying not good in a more precise way is like if you give this code not cleaning up, like user plot 2, and then if you gave this code to someone else, they are not going to won't be able to reproduce it. So in a data science environment, what I mean by not good is it's not going to be reproducible to someone or to you as well. So like sometimes you got one project and you got another project, and if you mix that up, you cannot reproduce another one because somehow the other project depends on the other one, and you don't want it to happen. So you want to separate every session from each other and clean up. So that's what it means session. And this concept is kind of easy to understand, but like the question is about how you can actually, practice it. So like I say, like there's an assignment, regarding assignment, there's two options. One is arrow assignment, and then there's equal assignment operator. And I say most of the time you should use arrow. And then but inside, like when you're setting an argument to something, then you should equal. So whether there's some similar principle for the session. Yeah, fortunately first there is. So one is if you go to tools, global options, there's something you should do. So usually if you go to general options and general, so everybody on the same page, can you see the general here that I'm seeing here, workspace, whatever? If you can see that, please type 1. Yeah, good. So one thing I strongly recommend to every my student whenever I'm teaching this is uncheck this box. Restore our data into workspace at startup. Don't do that. And then set workspace to our data on exit. Never. Why I recommend this? Because every time you exit, you close your RStudio and then you open the RStudio again, you're going to start over. It's going to be refreshed, cleaned environment. So this is better. So the first thing you should do is never check this box and then save workspace to our data on exit. Never. That's one thing that you should do, so that you can have the clean environment for yourself and for other people. And the other thing I strongly recommend to do is this projecting. So have you used the RStudio project? Did you use the RStudio project before? Good. Marisa used it. Kimberly, no. Yeah, if you haven't used it, I strongly recommend to use it. So it's kind of same idea. So like if you're cooking, one of the like things that we all dislike, at least that's for me, is I don't like washing dishes because it's too time consuming and not very exciting. And when you're actually making dishes, that's exciting. Like there's some improvisation, creativity, and like effort. But then washing dishes are all the same. It's all the same. But fortunately first, and when it comes to data science, when it comes to R, you don't need to worry about washing dishes. You can just set R project, and then each project is separate from each other. It's like as if you are creating several different kitchens. So it's the same R Studio, but when it comes to a project, you have several different versions of kitchens. So one kitchen is for stir fry, another kitchen is for chicken soup and things like that. And it's pretty easy. So just click this button and you can set a new project. And you already got a directory. Click the second one and browse. Here we have just one directory. You can set it code, but that doesn't make sense. Set it the project at the project level because you have one project. This is the file path. So I'm going to choose it here and then create a project. So now we got a nearly clean environment. So if you look at the packages, there's no ggplot2, whatever, and all the variables are clean. So this is actually better than just using RM, this stuff, RM list ls using this. This is a much better way. And there's a slightly more advanced technique. So there's other tips that other tips I can share. So this is a list of the things that recommended by Roger Pong at Hopkins. He's teaching applied statistics. So he emphasized this checklist. If you want to make your project reproducible, start with science. Don't do things by hand. Don't point and click. Teach a computer. Use some version control. Don't save outputs. Set your Cs. Think about the entire pipeline and so on. But I strongly recommend to actually read the post and understand what each point is about. But here what I'm saying is like just thinking about the cooking. So whenever you're cooking, you want to make your environment, like your sink, your plate, your oven, everything clean. So like the kind of food that you cooked last time kind of influence the food that you are cooking now. So it's the same principle. So every project, every session should be independent from each other. So that's good practice. And so that's what I'm emphasizing here. And if you and there's another like nearly good package or tool you might want to check out. It is called here. So those here package. So for those people who are already using our project, this is maybe like the second thing that you wanna learn about here. So I usually hear all the time. After dplyr, ggplot2, maybe there are some other packages that you want to check out. So one is here, the other one is per, and the other is glue. So to me, like these are kind of 5 basic packages now that you should master. So dplyr for data wrangling, ggplot2 visualization, and here for reproducibility, and per is for functional programming, and glue is a kind of different one. It's a string. It's for string operationalization, but we don't cover that yet. So I don't explain why is it here, but like, but here is just beautiful. So you like this concept, like having a clean and independent environment, and you think that that's good for your work and for collaboration. I strongly recommend to check out here. Here is awesome. Here is created by statistician and a software engineer called Jenny Bryan. And she's awesome. Okay, so that's here. And one other thing that I want to introduce you is called package name Pangman. So anyone using Pangman? Or Pangman user 1. I'm not using Pangman 0. Yeah, good. I'm always excited when people are not using it when I recommend it, because it's something new and you can pick it up. So one of the annoying things is going back to asking Marisa's question about, you know, like my code is cluttered because I got like a bunch of copy and pasted code or declarative code, and I want to find a way tidying things up. And one of the things I've seen is something like this, you know, like install 3 packages and then loading them one by one. So have any of you done this before? So install several of them, and then that's my code. Pretty good. Yeah, pretty good. And here's a better way. So instead of this, you can create just one, install just one package, and I can write a slightly different code. So what this line of code means here, if this Pacman package is not installed, so this exclamation mark means not, then we are going to install packages. So this the line number 126 is basically I'm telling my computer, I'm teaching it, hey, please check whether I install Pacman in my R, and if I don't, please install it. So Pacman, and then in the Pacman, I'm now searching the namespace. I find the function called p_word, p_word. And if you look at the explanation for this is beautiful. This is a wrapper for library and require. Wrapper for library and require. And wrapper is a kind of term that you use a lot by programmers. Maybe that's a little bit confusing for you. So it's basically kind of higher level function. So there are so many functions and they have some different documentation. And here I'm just providing a better interface or simpler interface that can access to these functions. Yeah, so the way it works, so I got a Pacman and then using a p_load function coming from that. And then what I need to do is just to list the functions I want to install and then load. So here is a list of 9 functions, ggplot2, deploy R, and then broom. And if I do this, what's happening, so this is the input, and the output is, what's happening is, if this function checks whether this is installed or not, so that's required. If it's not installed, then it's going to install this, and then it's just going to load it. Same for deployer and same for broom. And if you check the global environment, you see that these 3 functions now all in. Yeah, so Pacman is yeah, like Felix said, it's very nice and streamlined way of getting multiple packages on board. So I love Pacman. So here maybe 2 packages I recommend or check out is, one is the Pacman and the other one is here. And if you don't want to use Pacman, you can actually do like this using add apply. So package names, I create a vector called pkgs. It includes 3 package names. And then, so I'm using add apply, package, library function, and character only, and then it's gonna work. So you can do that as well. But you know, to do this, you need to understand why it's add apply and so on. So if you don't understand why it's apply family, maybe then it's kind of hard. Yeah, we are going to touch on why it's apply and other things in the next one. So now let's move to 02, data structure. Okay, so far so good. Do you need another break? So if you need like break, please let me know. So we're gonna have a break pretty soon. And this time it's going to be 10 minutes instead of 5 minutes. And sorry for like 5-minute break. I think that was a little bit cruel. Yeah. Okay, so then let's have a break for now and 10-minute break because we are moving to the next one, data structure. Do you need like a 10-minute break or 15-minute break? Either is fine for me. 10-minute or 15-minute. Yeah, 15-minute break. Then let's do 15. We don't need to rush in. I want to respect your pace because, you know, like you guys done lots of things already. And I feel like I'm standing between you and rest of the day, maybe nice dinner. So let's have 15-minute break and then come back. Sounds good? Okay, 15-minute break. It's starting now. Hey, if you can hear my voice, then please type 1. I just want checking in who's back and who's not yet. Good. And one thing I'm gonna promise is I'm gonna end this at least 15 minutes earlier, and if possible 30 minutes earlier, because I know that I noticed that everyone is tired, and I don't want to push you to suffer any longer than that's necessary. Also, some of the things that I'm gonna cover this session is actually already covered by the iBootcamp. So just the thing I want to emphasize is maybe something that's not covered in the iBootcamp. Thank you for recognizing our shared humanity. Yes, yes, that's true. My kid is playing outside, so actually I also need to. I just kind of like knocking the window. So Dad, when are you gonna be finished here? So I understand that. So anyway, so let me share the screen. Okay, I'll just give me a sec. Yeah, let me share the screen. If can everybody see the screen again? If you can see the screen, it sounds good. Yeah. So again, so to me, like there's a perfect kind of parallel between, at least to me, there's a kind of perfect parallel between data science or programming and cooking. So that's why I'm using lots of cooking analogies. So in cooking, I say there's fast cooking and slow cooking. And to me, like the kind of equivalent in data science is maybe in programming is objects and functions. And in the last session, we kind of focused on the function side, like what is the function does and what is the argument and how you can get to the documentation of the function or the package, or how you can install and load the multiple packages in a more efficient way. And also talk a little bit about reproducibility. But in this last session, I want to talk about data structure. So, but I want to talk about data structure in a kind of more, again, more accessible and intuitive way. So to me, the way I understand data structure is, it's just something like ingredients. So if you want to master cooking, whatever the cooking tradition that you want to follow, that basically means is you need to understand like different kinds of ingredients, whether it's food, or veggie, fruits, or aromas, spices, and so on. And you need to understand how you can combine them together. I mean, obviously, you need to know how to deal with the knife and heat and whatever cooking method you're using. But like the fundamental thing is you need to understand ingredients, like what is good for it, what is not good for it, and so on and so forth. And in the data science, maybe you can say the same thing about data structure. So whenever you are getting started in R or Python, this is actually the first thing you're going to learn. So after Hello World and some explanation about programming, what is R, Python is, and so on, and then you are getting to like exposed to like many hours of explanation and introduction about data structure. So I think you've gone through the same thing. So if you have at least a basic idea about data structure in R, like what is a vector, what is a data frame, then please type 1 so that I can see how many of you guys have some experience in data structure. So Maxine is 1. Yeah, so many people have 1 actually. So you guys know about what is data structure, like different types and so on. So this is a kind of overlap. So that's why I don't want to spend like an entire hour about this, because we already know about some background information. But what I'm going to explain is something like a little bit more about my experience. So in my experience, what is good about what this particular data type is good for what, and so on. So it's more about like sharing, again, rather than teaching, sharing my experience. So in case this is a little bit small, I kind of enlarge it. Maybe it's better for me to show it in the web browser. Yeah. Okay. So can everybody see this this diagram? there's like a data type and stuff. Yeah, to me, this schema is pretty useful to understand what is an object is. So we already talked a little bit about vector. So there are different kinds of vectors, like a character vector. So everything is like you can think about, you can create a vector of student, create a variable name student name. So I can create a name of like my name and then Ivani, Tadi, and so on. That's going to be character vector. And then numeric is obvious. There's everything's number, that's numeric. Then if everything is date time, that's going to be date time. And logically is basically whether something is true or false. True or false, true or false, that's going to be logical. So there are different data types. And here, a data type, what I mean is a single type of data, homogeneous, and just one dimension. So that's data type. And we can put them together in multiple ways. So if we put these, so if we put like a different elements together in, so actually here, maybe it's better going back to the iStudio. So I'm going back to the iStudio. So let me show you an example. So there are different ways you can put this together. So I'm gonna create I do live coding. So I'm gonna create, I code chunk. So, okay, so here is a character vector. So the big example is CA concatenate DC. And you see that in the global environment, you're going to see there's a new vector called CHR that contains 3 character elements. And I'm going to create another vector called num. It's going to be integer from 1 to 3. And then we can put them together in multiple different ways. One is a list, CHR num. And if you create a list, this is what's going to have. Okay, a double box bracket and then double box bracket. So in this dimension, there is one element, and that's ABC, and another dimension, that's what this 1, 2 means. There's a number 1, 2, 3. But you can put them together as data frame. And then I can just name it character number. And this is the output you're gonna see. So like, so there's 3, so if you have only number, so then there's the num and then num2, only numeric vectors like num and num2, then you can put them together as a matrix. So there are 3 different ways, basically. If you get, if you exclude this vector option, there are 3 options for you. One is creating a list. So you got a multiple vectors, you can put them together. So that's why I'm excluding vector options. You can put these vectors together as a list. You can put these vectors together as a data frame. You can put these vectors together as a matrix. But in the matrix, you say there's a homogeneous, which means in the matrix, every vector should be numerical. So unless you are putting these only num and num together, num2 together, then you're going to use all of these things. But if you are using num and character vector together, then you can, your option is basically 2. Either you can put them together as a list or data frame, right? And then something that I'm trying to explain here is when data frame is good, when list is good, when matrix is good. But before doing that, it's the same thing. Can anyone have intuition when putting vectors together as a list is good, when putting vectors together as a data frame is good, then putting vectors together as a matrix is good? Anybody had the intuition about this? So the situation of the problem is you got a multiple vectors, something like a CHR, num, and num2, like this. And then your option or solution is you can put them together as a matrix or list or a data frame. Under what conditions when one option is better than the other ones? Actually, if you understand this, you can understand many of things that you're going to learn, like from web scraping to machine learning and so on. So there's some kind of fundamental here. Any idea? Or you can just, if you like prepare, rather than giving like a large explanation, just sharing your experience, you're saying like, I don't like the list because it's too confusing. Yeah, so the question is, so the situation is you have multiple vectors, like this situation, like CHR, norm, and norm2, right? So multiple vectors. And then you have options. You can put these vectors together like a list, using list or data frame or matrix. And sometimes like using matrix is the best option. Sometimes using list is the best option. And sometimes using matrix is the best option. But like my question is whether you understand that under what conditions using list is good, under what conditions using data frame is good, under what conditions using matrix is good. Yes, Marisa?
So it depends on what you're trying to do. For my personal reasons, I prefer data frame because I'm able to do more with it. Specifically, if I wanted to use supplier, tidyverse, or anything like that, or if I want to use ggplot, everything works nicely with the data frame. However, there are some kind of multi-dimensional type of things that require matrix as well. So I understand how it works, but I rarely use matrix only if I have to. And if I can, I usually like flatten my matrices or my list into a data frame or a vector or something like that. But if you have like data, you want your data to be tidy and clean, a data frame. If you have something that is one-dimensional, I would suggest a list. But then if you have something that's multi-dimensional, such as, I know sometimes tweets do come in matrices, but depends on which package you use. Sometimes most likely they do come in data frames. So in our treat, which was reviewed in the boot camp, that does come and it does provide your output into a data frame. So essentially it just depends on what you're trying to do. But just for me personally, and just because of the ease of interaction with packages and what to get your data to do stuff, I've always been more I prefer data frames, but I do know that provides a lot of limitations, which is one of the things I encounter a lot of. I spend a lot of time like, okay, why need this to be in a data frame when, because I just can't work with it with the matrix or a list like I should be able to.
Yeah, that's absolutely beautiful answer. And then also Yeondu pointed out, so totally say that, so prepare a data frame because there's more flexibility with the different variable types or data types. And then Yeondu's explanation is matrix works if there are equal, we fix the same number of columns and rows. So it doesn't work well if there's a missing data or list of variable lengths. So, so these are all like very good intuitions, but I'm trying to also again kind of refine the ideas and then give it like a little bit more kind of well-defined framework for this problem. So again, most of the time you're gonna work with data using data frame. So that's the reality. So when you are doing data science work, and because before you're doing the modeling, before you're doing the visualization, you need to wrangle your data, you need to clean up, you need to understand the documentation, like what exactly each variable means and where these missing variables come from and stuff like that. So you're gonna spend lots of time on data frame and tidying it, right? So that's this area, data frame. And also data frame is kind of beautiful. So if you look at the data frame, it's kind of clear. So, okay, this is character and this is number. CSV is a data source. So here, data can be stored in multiple different ways. But in terms of structure, it's a kind of exactly the same as data frame. It's a kind of spreadsheet, like fixed number of rows and columns. Because spreadsheet is also, our CSV is two-dimensional, right? There are rows and columns. That's how the data is stored. And each cell represents different values. So that's, I'm responding to Erica's question. Yeah, so here the data example here is CSV and the spreadsheet. They are all looking like data frame because they're rows and columns. And database is a little bit complex. Some database has like a traditional database, the relational database having the fixed number of columns, but like there's also something called non-relational database, and it doesn't exactly look like spreadsheet. So there's no fixed numbers of rows and columns. So that's one example. So for example, if you directly get a data from Twitter API, that doesn't look like a spreadsheet. It's a JSON, and then JSON looks more like a tree. So there's node and many branches. There's a root and many branches, right? The same for the HTML. So most of the web data or digital data, whether that's website or mobile apps, things like that, you're getting there. It's like HTML, XML, JSON, those kind of stuff. They are all in a tree-like structure, not a spreadsheet-like structure. Yeah. So you are going to see data frame a lot because it's so clean and it's easy to see different types of variables and checking their types, if the type is correct or not, if there's missing value in just one space and so on. But the downside of data frame is there are two things. One is that you need to have fixed number of rows and columns. So if it doesn't it's also data you are getting it doesn't have that kind of structure, like the example I gave earlier, like HTML, XML, JSON, like Twitter, like tweets, websites, and so on. You need to think about like, so that's going to be not data frame. The type is going to be a list. Because a list is also it can contain heterogeneous variables, but it doesn't need to assume that there is a fixed number of rows and columns. So in the list, each element and each dimension can have different ranks. So maybe one dimension has five elements and another dimension has only 3 elements and so on. So the inconsistency is fine. So you need to sometimes know about how to go back and forth between list and data frame. Another way you are going to see list a lot in R is model. So there's empty cars built-in data in R. So this is what empty cars is. And then let's say I'm gonna run a linear regression model here. I know what I'm doing. I just putting 2 variables from this data and then see what I'm gonna get. And then if you look at this, there's some output. But if you're gonna save this output to model, maybe there's model. Maybe there's model. And then if you look at the global environment, I'm gonna see this is a list of 12. What that means is that this list has 12 dimensions, right? So model, and you can see there are different dimensions. And dimensions have names, there's a coefficient and so on. Yeah, so Marisa saying Twitter hashtags or URLs are hard to contain in a data frame. Yeah, that's exactly right. And you can see that each dimension in this list representing different aspect of the model output. So when you are getting the kind of non-traditional data like tweets, websites, and so on, web scraping, the cool stuff that you're going to learn from the SICSS, this is going to be the original data, so it's not going to be having fixed numbers of rows and columns. So that means you're going to have some that looks like a list, and then you need to turn that into data frame if you want to clean them up. And that's one data frame. And then, so the matrix is like, so like Yeon explained, and then also Marisa explained, most of the time you don't directly deal with the matrix because if you're using statistical packages, it's kind of hidden inside. So you are putting in data frame, you're getting the data frame out or list out. But in terms of the actual computation, it's all going to be matrix. So anyone has done machine learning, like text classification, image classification, or just the topic modeling or clustering, whatever. Anyone having experience in machine learning here in this group? Yeah, 1, Yeah, if you've experienced it, you can just type 1, 0. Yeah, so I think you're going to learn machine learning at some point in SICSS. And then one thing that you're going to do, like when you're doing machine learning, is like before you're going to learn the algorithm, you need to define the input data, right? So the input data, and then algorithm doing some predictions based on the input data, and you're going to have the outputs, right? And then for the input data, if the input data is a mix of variable, then you need to find a way to turn this like data frame list, whatever, into a matrix. So that's a kind of feature engineering process. And why we turn everything into matrix? Because if you think of what computer do, so for humans, everything makes sense. But it's false or through this large. So if you go back to this, for humans, so when you're working directly, we are spending lots of time on data. Everything here makes sense. Character, numeric, datetime, Raster makes sense because you understand each data type. You can deal with it. We can, it can mean what it can mean, whatever. Yeah, DFM. That's one example. N stands for matrix. So that's one. But if you think of a computer, what computer does is basically they're just counting. They're counting numbers. So if you're doing the machine learning, what that means is you are just giving the computer a big matrix, and then they can work with it, and then doing the computation, and then making predictions. So before machine learning, I think that most people don't directly deal with or think about metrics a lot because it's kind of hidden in the statistical package. It's happening behind the scene. But in machine learning, it's kind of one of the things that we need to deal with it. It's not difficult because it's usually function that can turn, data frame into matrix, something like that. So in terms of the practice, it's pretty straightforward. But just to, it's useful to know that sometimes in that process, matrix is very, very useful. And why computers love matrix? 2 reasons. One is they only understand number. That's one obvious reason. The other reason is if you're doing very computationally heavy and complex work, matrix is best. It's the fastest object that you can work with. So you gotta store like a very messy data, the list is great, and you gotta clean up something that data is framed great, and you speed up, then matrix is the best. So that's how I understand about this storage type. Any questions about this? Yeah. So there are lots of like examples about here, but I think to me that's the most important thing that you need to keep in mind. So there are so many things going on, but you need to understand when list is good, when data frame is good, when matrix is good. Like Marissa said, for the particular type of work you want to do, or for the goal that you have in mind. To understand that it can make your code faster or more easier to understand for you or other people. So I'm going to skip these class vector stuff because it's covered in the iBootcamp and not necessary for you. So most of things already covered. These attributes, factors kind of stuff. 2D dimensional. Yeah, these are all covered in the iBootcamp, so I don't gonna go over that again. So I'm gonna close it with just introducing what we're gonna cover tomorrow, and then end there. So tomorrow we are going to cover tidy principles. So anybody knows about tidy data framework? There's actually a famous paper by Heather Wickham.
I think no one's going to jump first, but I'm pretty sure that it's like the tidyverse framework essentially. And yeah, I'm not sure if it's like a pun intended by it, but it's arguably one of the tidiest way you can have all your data set up.
Yeah. So one idea. So I think like if you actually read the paper, the Headley's paper, he gave the Anna Karenina the Tolstoy book. So there's the first praise sentence coming from the book is like their unhappy family is in so many different forms, but happy family has the unified form. I mean, it's not exactly the quotation, but like that's the gist of the sentence. So what it means is messy data are messier in so many different ways, but the tidy data having a unified form. You know what I mean? So in the real world, data is messy in a way that it's not true. It's not like a very clean and organized way. And what it means is your job is going to turn that into like something that you want. But the point is that like you need to understand two things. So one is what is going to be the outcome? What is going to be, you know, the output looks like? So the paper and then his package kind of defines this is just something that output should look like. And then he's going to cover, okay, there are different cases of how things go messy and then how we can gonna deal with it. And then here, understanding data structure actually pretty good, giving us good foundation, because if there's something wrong with the data frame, what that means is something is wrong either in row or in column or row, right? Or names or values, something like that. So that's something that I'm gonna cover on tomorrow. So I'm gonna introduce what is a header list or tidyverse. So he's the one behind tidyverse. What's the header list idea about tidy data? So what's the output of if you do cleaning process, what's the outcome should it look like? So it's the same thing for like whether you are playing a musical instrument or again cooking, same thing. So you need to know so if you're, for example, baking apple pie, you need to understand what is good apple pie tastes like. And if you're playing a violin, then you need to understand what's like a good what's the good violin playing, sounds like. So if you have the conception in mind, then it becomes easier for you to like understand, okay, this is the destination, this is the goal, I should get there. And then, so that's the first step. And the second step is going to be like recognizing the patterns of the messiness. And then if you understand the patterns of messiness, then you can now get working on how can fix them. So this principle, kind of the understanding this step-by-step principle is important for data wrangling, also for understanding the steps involved in data visualization. So like the same thing. So I don't want to go over like every detail involving this tomorrow, but I'm trying to talk about more about kind of meta learning kind of stuff. So how you can learn these things better. So that's something I'm going to focus on tomorrow, because I know that Chris, I can cover most of the materials that you need to run. So it's more kind of complementing the material and so like showing you like a little bit more about pedagogical side. But here are some maybe good ways you can use to learn better, learn this difficult subject better and quicker. Okay, so this is actually end for today. As I promised, I'm gonna spend too much time on this, but I'm gonna linger here 15 minutes longer if that's necessary. And if you have any questions related to our studio, learning programming, and I'm happy to respond to them. But otherwise, this is the end, and then we are gonna join again tomorrow. Thank you so much for your attention. I know it's a long day, so hopefully you can get rehydrated and get another drink and food.
Thank you all for watching. For more information on SICSS-Howard Mathematica, visit our website, follow us on social media, and join our email list.